Welcome friends to this module on health survey data. We are on the second lecture and it is on data measurement and scaling. We have already discussed about the research problems, the very foundation of research hypothesis building, how we start with a basic research, what are the different types of research problems we already discussed in the last lecture. In this lecture we will clarify you about different types of data, their measurement and their scaling. Why we are discussing, because this is very useful especially in filtering the data, especially in which scale of measurement we require in the data. Those pre filtering analysis is very essential before any sort of inferential statistics we derive from the data. Now data, as we all know, that these are set of values both qualitative and quantitative about one or more objects. Okay, so this is data is all about different sets of values, and this gives information in raw or in organized format. That could be very possible in any format. Data is available. So data use are usually alphabets, numbers, symbol, and represents preferences, ideas, objects or their categories, etc. These are measured and collected, reported and analyzed. So data actually accordingly produces graphs, tables, useful images with their appropriate visualization. So this is where the data which we are going to deal with, we have already dealt in my previous module on NPTEL. But this time it is more applied based, and it is more health related research, and where we will be using unit level data, ISDS data to some extent. Then we will be use Stata software for the analysis. And regarding health data, these are all about observations related to health conditions, reproductive outcomes, different causes of death or quality of life of the individual or population. This ranges from health data includes geographical factors, cultural, scientific, financial, then your statistical, meteorological, natural, transported related issues. Okay. So there are various forms of data connecting to each of the factors. Now from the data we may draw certain direction, certain frequencies about the occurrence of heart disease, cancer, injuries, infectious diseases, etc. Okay. What do you mean by data set? A data set is an ordered collection of data. Okay, when the data is collected in a order, and they are called data set. The data point basically singling out the particular observation, okay, or a particular point. All right, like here in that example about use of medicine, traditional and modern medicine, we have different variables like modern medicine or traditional medicines. Within the data set we have discussion about observations, we have discussion about data point, okay, and data point basically the exact entry may be in 6.37 or 7.54 etc. are called data points. What do you mean by raw data? This is basically pre-processed data or unclean data, okay, just the information that is before proceed to analyze or clean, and or before organize or analyze are called raw data. There are number of open-ended responses to a survey, some survey responses are there. So a particular value might have been entered. If those are all put to in different forms are called raw data. On the screen I think we have already shown you earlier or in my previous module, this is in fact called the raw data. All the bytes and their codes are entered. We are referring to NSS 75th round raw data, okay, published by Mosby, Government of India, Ministry of Statistics and Program Implementation. Ministry of Statistics and Program Implementation gives these forms of data. A sample of information is given, like health expenditure of 90 individuals per year, and then their health expenditure data is presented. So, at this moment these are completely in raw form, we cannot guess anything out of it. Okay. Coming to some criteria that describe and evaluate the data set are like you have to define the criteria. Those criterions are purpose of the data, nature, specification or methodology, accuracy or correctness, sources and time period. Okay. So, the time period has to be specified, the sources of the data has to be specified, and the exact methodology which is used or specified, that has to be very clearly understood. So, like purpose, the objectives of the study should have been clearly spelled out. Okay. So, coming to the nature of the data, we may define each of the element within the data, like their unit of measurement, their specification of variable and their categories. And in the questionnaire or in the methodology, we are supposed to talk about the sampling techniques, their size, their questionnaire design. Okay. And like in the sources, we are supposed to find out to talk about the exact source of the data. It is necessary to reduce the risk of misinterpreting the set of data during use. So, in the time period, I think all the database we always refer to the time period, and in due course of time I will let you know about its time periods. Coming to the sources of data. So, regarding sources of data, we have two types. One is called primary, second one is secondary. So, the primary data, I think we know that we usually follow survey methods, survey directly with the individual, with the person, or by telephonic method, or by email approaches, and or sources of primary data could be your observations, by personal observation, by mechanical observation, by laboratory testing, or by laboratory experiment or field experiment. Okay. And in the secondary data sources are like if you are collecting from the library or from the government sources or from the trade or professional bodies, private business firms, or advertising media, university research organizations, etc. So, basically the primary sources are the closest one so far as the information from the direct person or the respondent is concerned. Whereas in case of secondary one, these are usually for some forms of generalization, some forms of interpretation of the primary sources. And coming to the sources of some health database, since we are going to use it in our research, in our discussion, in our succeeding lectures. So, those are like National Sample Survey Organization (NSS), published by Ministry of Statistics and Program Implementation. It is called Mosby. Second one is called National Family Health Survey (NFHS), published by Ministry of Health and Family Welfare (MOHFW). And third one we are more interested to explain to you, and since these databases have more dimensionalities. So, like we have another one is called longitudinal aging survey in India. Okay, these are also called LASI, LASI, published by International Institute of Population Sciences. About the type of data and their nature, we have already discussed that they may be primary or secondary. Now we are discussing on the basis of their nature, which nature it may, they may be categorical or qualitative, or may be numerical or quantitative. Okay. In case of qualitative one, they deal with the description, some attributes, data can be observed but not measured. Okay. So, those are called qualitative data, or called or having certain qualities or colors, smell, taste, gender, sector, etc. Okay. So, those are not quantified as such. We may code it, but codings are not called quantification. Whereas coming to quantitative data, we have particular numbers represent to the context. Data can be measured and can be scaled correctly. Okay. So, again the quantitative data are of two types. One is called discrete and second one is continuous. Discrete one, where the discrete choice function is defined, like number of hospital consultation or number of doctors consultation. It is not converted with certain decimals. It cannot have clear cut what is called continuous series. It is clearly discrete one, either for one consultation, maybe 5 consultation, it cannot be a 5.2 consultation. Okay. Similarly, coming to continuous data, speed of cars, height of the children, okay, maybe in age, not in round figure by its years, rather age in any number maybe of years, month, days, time, there are lots of possibilities. So, even income of the person, it's possible to define in fraction. So, this is all about called quantitative data. Now, based on time and entity, data can also be divided into 3 broadly. One is called cross sectional, second one is called pooled, third one is called time series. So, cross sectional, time series, and the middle one is called pooled, where both the type of data are actually entered, like the cross sectional observation, individual behavioral observations are presented at a particular period of time, whereas the context in case of time series is actually repeated over time. Okay. So we are basically doing what in the pooled, we are actually mixing these two together, cross sectional, and those cross sectional units are represented at different time periods. And these special case of pooled data is actually called panel. So, all pooled are not necessarily panel. If the time component does not represent the individual person over time, then that cannot be called panel. Rather it is simply called pooled, because in the pooled the different cross sections might be added in different time periods, but we are concerned in panel or the longitudinal data where the same person, same observation is repeated in different time period. Coming to cross sectional data, I think I have already mentioned that it is the same point in time when the variables are collected or the observations are taken. In case of our 75th data on social consumption of health on health or social consumption health survey data, we have entity like A, B, C, D or the E, F, G, H, those represents persons, and the time period is same, that is 2021 time period is same. So, if it is 2021 or if it is of 15, 16, then or 17, 18, in fact this if you are referring to 75th data, we have to stick to the particular year. Now, this is for simplicity, any year is taken. Okay. So, similarly about variable, there could be any entries, and we will find out what are the relevance of those entries. About time series data is on set of observations on different values that a variable takes at different time, okay, at different time. All right. So, those time series data are collected at regular intervals such as daily, weekly, monthly, or annually. Such examples are stock prices, weather report, unemployment rate, etc. Whereas the pooled one we have already said, which is the mix, the elements where both time series and then cross sectional units are present. In pooled data, different cross section entity is surveyed over time. So, we are saying, this is same period, and the entities is studied in 2 time period. This is the in the same year 2 portions are studied, and in another year another 2, maybe A and C are the same person. If the same, then it is completely called a panel data. Okay. Panel data, pool data, this is we are explaining in this example, we are explaining pool data. Pool data, basically we are adding all the cross section units. A and C are not same, they are not same. Okay. So, or B or D are not same, but time period, we are simply pooling the 2 time period, 20 study and 21 study. Okay. But in this case, in case of panel data, A is present in 2020 and it is also available in 2021. Similarly, B in 2 time periods. So, and then one of the example data set we are going to take is from LOSI, okay, Longitudinal Aging Survey of India. So, different forms of data are there, like alphanumeric data, text data, image data, and audio data. So examples, tables from the data file is here. We will also work with the exact data set in the respective lecture hour, where we will mention about what is this alphanumeric. Alphanumeric data, the famous example for it is our Aadhaar card, okay, maybe our PAN card number, okay, it is alphanumeric. Okay. It has alphabets, it also has numeric numbers. Okay. And text data, where only descriptions are given, where only some sort of explanations are given on the text. Image data, where picturization or visualizations are made. Audio data, where you are supposed to listen and interpret your voice signals are given based on their frequencies. Some forms of interpretation could be done. Okay. On the screen you have a raw data from the 7th round of a national sample survey on enterprises. The point of importance here is that we deliberately want to show this figure to highlight this color. Look at this color, these colors are in fact red. So, red indicates this indicates your data is in string form. Had it been black, so black could have referred to your numeric data. The string form, while at the time of interpretation we will convert it, and then only any sort of numeric estimation would be possible. So, we will do some de-string operations, then our data will be refined for interpretation. I think in the startup window it is given, this is called a string data, and it is shown what is the type of data, it is shown here. Okay. Now, after giving the background about data, different forms of data, there are different types of data. Okay, they are nature, by certain time, by their coverage. Okay. Now, we are moving to the explanation of measurement. what do you mean by measurement and how it is relevant in the module. So, measurement is basically the assignment of number or symbols to characteristics of objects according to certain free specified rules. Okay. So, those assignment are especially numbers or symbols are simply called measurement. Quantifiable objects are easy to measure while and also highly accurate. Qualitative objects are quite difficult to measure and less accurate. Coming to your one example called height, we measure it through certain scales. Okay. So, that is part of our measurement. Whereas, in case of scaling, we are supposed to put them in a continuum format. Okay. The generation of a continuum upon which measurement are made or measure objects are located is called scaling. Okay. Primary scales of measurement are discrete scales or continuous scales. Okay. So, discrete scales we have already based on the discrete series of the data, maybe in categorical form, maybe in nominal form or in ordinal form. So, nominal form has no orderings, where in case of ordinal form they have certain orderings. In case of continuous scale, it is called interval data or it is also called ratio data. All sort of measurement inferential statistics, mean, median, mode, standard deviation, etc., we can do it on the continuous scale data, but it is not possible to do it on the discrete series. Okay. Then when we defined about the data set, they are basic understanding about measurement. Now, we should understand the characteristics of measurement scales. What are the characteristics? The first characteristic is called identity. Okay. The identity means we need to refer to the assignment of numbers to the values of each value in the data set. Okay. The particular number which is assigned is important so far as identity is concerned. A serial number is important as well. This considers a questionnaire that asks for a respondent's gender with the options about male or female. Okay. The values are entered as 1 or 2 or at the reverse. 1 may stands for male and 2 stands for female. Arithmetic operation cannot be performed on these values because they are just for identification purposes, not for measurement. Okay. And this is a characteristics of a nominal scale which we have just mentioned. Now, coming to another characteristics called magnitude. This is basically discussing about your size of your scale, where the numbers have an inherent order from least to the highest. They are usually represented on the scale in ascending or descending order. Okay. And the position in a race, for example, is arranged from the first, second or third to the least. This example is measured on an ordinal scale because it has both identity as well as magnitude. Okay. So, ordinal scale have identity basically of their position and their level where they lie. Okay. So, their magnitude is also defined in case of ordinal scale. There are some scales called interval scales. What about equal intervals? Equal intervals means the scale has a standard order. The difference between each level on the scale is the same. So, this is not the case for the ordinal scale. Scale as per the example highlighted before. Where in case of positioning first, second or third, it may not be the fact that it has equal distance. Okay. Like each position does not have an equal interval difference. In the race, first position may complete the race in 20 seconds, the second may be in 20.8 seconds, while the third might have completed in 30 seconds. So, that it is not necessarily that the fact that these frequency points are not are of equal scaled. Okay. A variable that has an identity, magnitude and equal interval is measured on an interval scale. Another characteristic is called absolute zero, which kind of data has the possibility of absolute zero and it has certain value. There is an existence of 0 on the scale and is defined by the absence of the variable being measured, okay, and that is no qualification, no money, does not identity any gender, etc. So, like absolute 0 is a feature that is unique to a ratio scale. Okay. So, 0 is not defined in some of the previous examples which we have cited. Like in the temperature scale for Fahrenheit or Celsius, we are not referring to 0 values. It has certain range, certain intervals. Now, coming to the level of data measurement, the level of measurement of a given data set is determined by the relationship between the values assigned and to the attributes of that particular variable. What about nominal scales as against ordinal scales? Nominal scales used for labeling variables without any quantitative value. These are termed as classificatory scale, and this shows the quality of the data. This assigns responses to different categories. No numerical difference between the categories is defined in case of nominal values or nominal scales. Categories are distinct and homogeneous, okay, but that is very clear in this sort of data. So, the weakest tool of the measurement with no arithmetic origin or an order or distance relationship. Basically, in nominal scale, this is in fact the weakest tools of measurement, since it does not entertain any forms of arithmetic origin. Okay. And this is not a measure of quantity, we have already mentioned. This measures identity and difference only. People either belong to group or they do not. This kind of explanation is important. Examples are like nature of treatment. In our 7th round, we are going to discuss about nature of treatment for traditional or modern treatment. Hair color, maybe brown, or maybe black, maybe blonde, maybe gay and others. Sectors, those who stay, they might be in rural areas and urban area. Here the numbers do not have numeric implications. They simply talks about a label, not a label. Okay, it's simply a label with a number. This makes no difference if the order of categories is changed. If we are simply flipping the order of the categories, it's not going to change any sort of value. Okay. So, in the chart, like chart gives number of males and females in a given class. Male for number of students are 14 on the first example, and female they are of 17, and their frequency table is mentioned. Similarly, if we change their code, female comes first and male lies second. In that case, their frequency are simply flipped, not by their number. In case of ordinal scale, some ranks are given. The data has certain order, like standard of education we used to mention. So, these ordinal scales are used to interpret the relative positions. It has unequal units, do not know the numerical distance from each category to the next. So, the numerical distance is not possible, and this ordinal scales divides objects into categories and arrange them in order. More precise comparisons are not possible in case of ordinal scales. So, academic performance, we said high school level, or school level, high school level, bachelor and masters, etc. we can at best get their frequencies. Coming to the interval scales, we include all characteristics of an ordinal scale. In addition, it gives a unit of measurement with an arbitrary starting and terminating point. In case of interval scale, it has arbitrary 0, which is just a reference point, okay. But it does not have a true 0 value. 0 does not have any meaning in case of interval scales. we only compare the gap, the interval between the points. We can know the bigger value or also how much bigger they are. These kind of things we derive. They have equal units. These data can be added and subtracted, but cannot be multiplied and divided. Okay. Like temperature, temperature doesn't have 0 degree Celsius or temperature. So IQ level, like we test for IQ level in the example, it doesn't have a 0 IQ level. There are some level of IQ. So no IQ is hardly possible. Coming to ratio scales, where we already mentioned that all sort of numeric interpretation, numeric applications are possible. This gives equal units, absolute 0 value, interval size is known, equal or constant. This measures on only one side of 0. All the mathematical operations are applicable in this scale. So, top level of measurement is possible with the help of numeric scale or the ratio scale. Now, weight, height scales, etc., where weight 0 means no weight, it has certain true value. Okay. Similarly, other example could be given. So, the primary scales of measurement, we have already said that nominal, ordinal, interval and ratio. So, we have given examples. This number 7, 8 or 3, this only indicates a position, a number. Okay, it is number and gives identification to this particular person, whereas third position, second position or first position, this gives certain ordering. Okay, ordering of finish, first position of finish and their time matters. In interval scale, the gap is more important between 2 points. Okay. So in case of ratio scale, any fraction of points are possible. So usually they are called scale data, ratio data, and then all numeric operations are possible. And some of the illustrations are given about primary scales of measurement. I think I need not spend much time. Like these are the order, the numbers and their identifications by their a serial number is given by their name. At this level, we will simply called as nominal scale. Once a 10-point ordering is made, whose ranking is highest or lowest, that can be interpreted in case of ordinal scale. Okay. Similarly, interval scale, we are supposed to give preference or their rating in a scale, maybe 1 to 7 rating or 11 to 17 ranking, or any ranking, but it has to be in a range. Ratio scale gives all sort of data points. So we have already discussed. Let us compare those 4 scales of measurement. So like all 4 scales of measurement, like order of value is known in case of ordinal, interval and ratio, whereas nominal it is not possible. Frequency distribution, all database has. Mode, the mode frequency, basically we can get this information in all the data. Median value, I think the nominal does not have any median value, whereas the ordinal has that that the qualities and all other database has. Mean, I think only 2 mean value you can derive for ratio data and interval data, and quantify the difference between each value. It is again possible in case of these last 2 interval and ratio data. Similarly, subtract and addition is also possible. Coming to multiply and then divide. Okay, multiplication or division is not possible in any other database except ratio scaling. So absolute 0 is only found, or it is defined in case of ratio data. So in short, let us give a summary of our scaling techniques. Scaling techniques are broadly of 2 types. One is called comparative scales and second one is called non-comparative scales. Comparative scales, where we can able to compare the points of one estimation with another one. In case of non-comparative scales, it is not required to compare, Okay, it's in most of the marketing techniques non-comparative scales are used. Okay. So, comparative scales include paired comparison, rank order comparison, constant sum comparison, Q-sort and other procedures, whereas in case of non-comparative scale we have continuous and itemized rating scale. We will explain just now. Within comparative scale, we have direct comparison of given object. So, this result in data in comparing the objects. The data are of nominal or ordinal, and are usually non-metric. Okay, no calculations are usually made. And non-comparative scales, I think each given object scaled independently of each other of others. Resulting data is in case of non-comparative scale is of interval or ratio, and these are in metric format. Okay. A respondent is given only two options to select between Honda Kona electric car and Mahindra Barito car. So, only two comparison if it is made, they by their price, by their mileage, by their charging etc., by their power. So, if two comparison is made, this is in fact called a paired comparison. We are simply pairing comparison. And I think coming to rank order scaling, we have to keep the ranking out of so many options for a particular target. Like in case of battery, we get MTK, Sucam or MTech, Exide, Amaron, Luminous etc. Out of all those things, we can ask to the customers to rank those options. Each individual object is compared with each other. Some ranking could be given. In case of constant sum, though in the ranking we only give arbitrary number, but there is no caveat or boundary of their choice. In case of constant sum, out of a certain limited number of entries, one has to compare. One has to compare. Like a respondent assign constant sum of units out of total units of each individual attributes of an object. Like suppose I just show it here, out of total, let it be 150 every time. Out of total, each group are supposed to evaluate out of 150. Your total points of feedback for a particular company could be of 150. So, related to each indicator one may give. Okay, so, your constant sum has to be constant, then you can able to give different orderings. Okay. In case of Q-sort, we are supposed to sort the responses. There are different questions and then the answers. So, those attributes could be sorted out. Like if somebody is observing or understanding point of view of social license to operate, so what should be done in case of production unit for oil and gas. The job title is environmental advisor is supposed to understand the social license issues, how society is giving license to operate. Okay. Now, in that case, there are different responses are taken. Out of those responses, 17 responses we have mentioned on this chart. Further we will sort it. Okay, sort it to three important indicators. Which are those attributes comes under more like to like I think, somewhat like how I think, and less like how I think. So, I am just taking some of them to some of these entries. First I have taken there as per my preferences, then accordingly others have been taken. Okay. So, like this. Finally, we can count which entries are important, like more like how I think, which one are more in number, okay, or which categories comes under the weakness of the company or not. Out of that, we can also put them in a scale to -4 to 4, or more likely to less likely, and in between some numbers we can enter. So, these are the process called sorting, okay, Q sort. Now, coming to the non-comparative scales, these techniques measure objects independently of other objects. These techniques measure one article at a time. These are also called metric scales or monadic scale. Okay. So, some examples like customer may be asked to judge Colgate on a scale of 1 to 5, 1 may be least favorable, 5 may be the most favorable. There are so many other sort of assignment or assessment, okay, for maybe for close up, maybe for Pepsodent toothpaste. Non-comparative scales are of two types, one is called continuous scale and another is called itemized scale. This is in fact the non-comparative scales is in fact widely used in marketing research since it is qualitatively built. Okay. First itemized first continuous scaling is explained here. The first one is called continuous rating scales, where we are supposed to give a continuity in our scaling. So, all the entries from unfavorable till favorable, a continuous scale is given, one is supposed to put a tick mark. Okay. So, respondents' attitude towards an object is judged by asking them to put a mark on the line from one extreme to another extreme. Otherwise, some points, discrete points may be defined and one has to put a tick mark. So, this is in fact called continuous rating scale. Another is called itemized rating scale. Itemized rating scales are provided with a scale that has a number of description or brief description associated with each category. Okay. The respondents are required to select the specified category that best describe about the object. So, this measures respondents' attitude towards an event or an object such as product preferences, perception, purchase intention, satisfaction, etc. So, the itemized scales are of broadly three types: Likert scale and semantic differential scale and Stapel scale. Okay. Most of the researchers use Likert scale. Semantic differential and Stapel scales are also used, but it depends upon the exact requirement. These are usually put Likert scale. Now, we are explaining as part of the itemized scale. We usually Likert scales are put in 5-point scale, okay, with certain agreement to disagreement from the respondents about a particular project, particular objects. However, some practitioners also advocate 7 to 9-point scaling techniques as well. So, each point of the scale has a corresponding score. The analysis can be conducted on an item by item basis based on the total score. So, from high to low, like here it is given strongly agree, disagree, undecided, agree and strongly agree, and its scores are given. Coming to the semantic differential scale, the word semantic is important, where the the person who is responding is given the choice to respond in a contrasting manner, either you from extreme base to extreme worst. The negative adjective or phrase sometimes appears at the left side of the scale and sometimes at the right. In this scale, suppose basically in the semantic scale, the responses has to be bipolar. Okay, it has to be clearly attaching the contrasting differences, okay, not like in Likert scale. Bipolar labels has to be there. The study like in an example about new mobile phones in the market, the respondent may be asked to put a mark anywhere between the two extremes to show how his or her attitude varies. If the extreme views are taken, that helps in taking better decision about the company, isn't it? The Stapel scale initially developed by Stapel, Jan Stapel. Stapel scale is a unipolar rating scale. So, one basically so it is different than that of semantic, because in semantic one we have bipolar responses, extreme references, whereas in case of Staple we are supposed to evaluate within one direction. Okay, it is therefore called unipolar rating scale. If when we know that our like Honda showroom for automobile, they know that our performance is better. It is not towards the O side. So it has to be from 5 to 10 onwards, not be below 5. Okay, there should not be any negative evaluation, but from 5 to 10, what is the best indicator? Okay, so the scale is made of even numbers of responses. That is another feature. We should note it down. Like 10 classes ranging from -5 to +5 without having any neutral point. There is no neutral point in this Staple scale. Respondents are asked to indicate by selecting an appropriate numerical response category which best suits to them. Staple scale is usually defined as a rating scale that is close ended with a single adjective, that is unipolar adjective. Okay. This helps to gather better insights about a particular subject or event, and this is similar to semantic differential scale, with the sole difference is that it has one side of the adjective. So, this is what we said, there is no zero value regarding ambience of a company. You can ask from plus to minus, okay, but there is no question of a zero value. Zero is not differentiating its responses. Okay. So, there are certain characteristics of Staple scale. I think some of them I have already mentioned, and some of are you may clarify from the slides. We will also upload for your reference. Why should you use Staple scale questions in your survey research? The Staple scale, as I already told you, that it gives very intricate result, give more insights, and this is very easy to administer. This reduce drops. Many person don't respond since you give a bigger scale. If it is very specific scale, they respond. These collect actionable insights, forces a response as there is no neutral value. Usually in most of our responses we give neutral value. So it forces the respondent to give non-neutral value to your data or to your questions. So Staple scale is usually used to conduct in-depth data analysis in your survey. So these are the difference, I think I have already mentioned, difference between Staple scale and semantic differential questions. So all those things I have said, for your clarity I have put it in a box, and these are referred to some of the publicly available documents. So for your interest, some of the readings you may follow to further prepare for your research work. I think I need not read it out. It is very clear. With this, I think I should end here. If any questions, please be free to write down and raise your questions in the live sessions. Okay, thank you.